Okay, so just to recap, all the nuclear power plants in the world today um, use nuclear fission, okay, of mostly uranium, but sometimes plutonium to generate electricity. It is a key factor. It is fission that we are using at the minute. However, there are drawbacks to that, okay? Although it releases a large amount of energy, it produces radioactive waste, there's a risk of leak or meltdowns happening, and there's only a certain amount of uranium available to us. If we were able to crack nuclear fusion as a power source, it'd be one of the biggest breakthroughs in physics ever. And whoever does it would be worth a huge amount of money. Why is it so difficult to achieve nuclear fusion on Earth? It is a problem with reaching those very high temperatures are required. But here's the thing, we have done it. We have achieved this on planet Earth, which is a massive, massive achievement for mankind. However, what we've found out is anytime we have achieved this before, the amount of energy we have to put in to get our hydrogen up to those very high temperatures where nuclear fusion will happen, we actually get less energy than that out once we get the hydrogen nuclei to fuse. Therefore, we're putting more energy in than we're getting out, so it doesn't really work as a process yet where we can get a net output of energy. However, we are continuing to research this. So one of the biggest projects in physics at the minute is called the ITER project. ITER stands for International Thermonuclear Experimental Reactor. And it is being built in the south of France. It is a bigger version of the jet fusion reactor that is in Oxford in England. And they do hope once this reactor is up and running, it will be able to produce a net positive output through nuclear fusion. They hope that this will be the kind of reactor before they build power plants using nuclear fusion. How it works is, where you see the people in this photograph working on it, that's where the fuel will be. The fuel is kind of shaped as a donut. The problem with nuclear fusion is it has to be at about 100 million degrees centigrade. We have no material that can withstand those temperatures, so we can't keep that fuel in like something made from metal, something made of glass, even something made of some of the hardest materials we have, diamond, would just vaporize in those temperatures. So what we use instead is a magnet. Okay, so the actual fuel at those temperatures doesn't touch anything. It's kept away from the sides of our reactor core using very, very strong magnetic fields. They do state this last little bit. I know it doesn't maybe seem that important. It is mentioned specifically in your syllabus. It costs a lot of money to do this. No nation could really afford to do this by themselves. No nation would have the technical expertise even to do this by themselves. So there are projects in physics that require international cooperation and provide all the money and all the expertise to have a breakthrough like that. And it is an important side of science that it is something that we work on in cooperation with other nations. Okay. What I want you to do now is to try and answer this question in your own words. The way you get better at writing about science is through practice. So try and think of a nice structure. Think of the things you could include when you're comparing fission to fusion. Think of the advantages and disadvantages of both. Try and put it into a nice structure and write your answer on that. And then in the next video, we will look at the things you should have mentioned for each of those.